Thermal energy transfer. Now, many people put cream or milk into their coffee to change the taste and to cool it down. And although the overall temperature of the coffee does drop, it's not from the creamer cooling it. Now, as we look at the particles in the hot coffee compared to the cold creamer, we can see that although they are both in the liquid state, the coffee particles are moving faster than the creamer particles. Because the coffee particles are moving faster, they will actually collide into the creamer particles at a higher rate, meaning it's easier for them to collide with the creamer particles than for the creamer particles to collide with them. As the hotter coffee particles collide with the colder cream particles, they pass on their kinetic energy. And this causes the coffee particles to slow down and the creamer particles to speed up. The slowing down of the coffee particles is what actually causes the temperature of the coffee to cool down. And we can feel the transfer of energy when cooking. Now take a look at the particles of the cold metal spoon and the hot soup. Again, the particles of the soup have more kinetic energy than the particles of the spoon. If the spoon is actually left in that hot soup, the soup particles would transfer their kinetic energy to the spoon. The soup particles would slow down and the spoon particles would speed up. And this would cause the soup to cool and the spoon to warm up. If you picked up the spoon after it had been in the hot soup for a while, it could feel hot to the touch. And because it's metal, it could possibly burn you, as thermal energy is transferred from the hot spoon to your cooler hand. So thermal energy always transfers from hot to cold. And thermal energy can transfer in three ways. Conduction, which transfers between materials like solids, liquids, and gases. Convection, which transfers within the same material like that soup. That happens in fluids like liquids and gases. And then we have radiation. This is the transfer of electromagnetic waves, and this one doesn't need matter. So thermal energy transfers always from hot to cold, and it always has the higher kinetic energy particles are going to be transferring their energy to the slower kinetic energy particles.